Alright, this one's clearly another P1 V1 over T1 equals P2 over V2, P2 V2 over T2 type problem, because we've got something that's got two sets of conditions. What volume will 400 dot mils of SO3 at 0 degrees Celsius and 760 millimeters of mercury occupy at 110 degrees Celsius when the pressure remains constant? So you see we've got two different temperatures telling us we've got two different sets of conditions here. It says also here the pressure remains constant. I'll show you how to handle that in a second. Alright, so we're going to set up our problem the same way we've done in the past. P1, V1, T1. And over here I'll put P2, V2, and T2. And since we want the answer over here, I'll put this first set of conditions over here. And the first set of conditions, it says 400 milliliters of SO3 at 0 degrees Celsius and 760 millimeters of mercury. So that's our first set of conditions right there. We've got a temperature, a volume, and a pressure, and they're all together. So the pressure here is 760 millimeters of mercury. The volume here is 400 milliliters, and the temperature is 0 degrees Celsius, which is going to be converted into 273 Kelvin, so that'll be 273 K. Temperatures here are always be in Kelvin. It's because we can never have a zero as a temperature, because remember it's going to be on the bottom when we do our P1, V1, whoops, over T1 equals P2 V2 over T2. There's no way we could ever have a zero temperature there, so we always have a Kelvin temperature here. Pressure 2. Now it says pressure remains constant. All that means is the pressure isn't going to change, so we're just going to make it 760 millimeters of mercury. Not because that's standard pressure or 1 atmosphere. It's because it says constant pressure, which means its pressures just simply remain the same. Now we're looking for the volume, so I'll put a question mark there, and the temperature, the new temperature here, is given as 110 degrees Celsius, so we'll add 273 to that, and that will give us 383 Kelvin. Alright, so what we're looking for here is V2, so I'll go ahead and isolate V2, and that would be P1 V1, and then I'll multiply that by T2, bring that up to the top, and T1 P2, so we take the P2 down to the bottom. That isolates the V2 for us. Alright, pressure 1 is given as 760 millimeters of mercury. Volume 1, 400 milliliters. Temperature 2 is given as 383 Kelvin. T1, 273 K. P2, 760 millimeters of mercury. Now I want you to see how all the units here cancel, because we've decided to use the same units for pressure. We've used the same units for temperature. And we know that milliliters will be the answer we'll come out with in the volume. It's going to come out to 561 milliliters. And just a note about significant figures here. Each of these contains 3 significant figures, so we're going to come out with 3 significant figures in our answer. And again, I'll just show you how the units all cancel out nicely to give us our milliliters at the end. Alright, so there you go.